Somebody files a bug report and it is 2 lines long. Messages sometimes don't arrive. No error. That's the whole report. So you open the app and send a message to a second device, and it works. You send 20 more, and they all work. And somewhere out there, right now, on a phone you will never see, a message is quietly not arriving. Here's what makes this one strange. The connection says it's open. The send call comes back without complaining, and the message never arrives. All three of those are true at the same time. So, what did opening that connection actually promise you? Let's answer that because the answer is smaller than people expect. A WebSocket gives you a connection. It stays open, and either side can send whenever it wants without asking first. That's the part WebSocket gives you. What it doesn't give you is a messaging system. It won't tell your application that a message was delivered, whether the other side is still reachable, who they are, or which of your servers is holding the connection. Ordinary web requests are separate calls. You ask, the server answers, the exchange ends. A WebSocket keeps the line open instead. And an enormous amount goes away with those separate calls. So let's find the exact moment it happens. It's one moment and you can point at it. Every classic WebSocket connection has a line running through it. On one side, this is an ordinary HTTP request and response. The browser asks, the server answers, and almost everything you rely on comes from that pair. On the other side, request and response are gone. What's left is a channel and messages travel it either way whenever there's something to say. That is the trade you make. And from here, one question covers everything else in this video. Does the protocol guarantee this, or do we have to build it ourselves? Now, the strange part is that a WebSocket doesn't start as a WebSocket. It begins looking surprisingly familiar. Well, almost familiar. It's an HTTP request to a normal URL, but it carries a set of headers asking the server to switch protocols. The browser also sends a random WebSocket key. The server transforms that key and sends the result back, which proves it understood a WebSocket handshake rather than treating this as an ordinary request. And then the server answers with a status code you see about once every 3 years, not 200, 101, switching protocols. Same connection underneath, different protocol on top. In the classic handshake, that is the last moment this behaves like HTTP. The browser hasn't stopped working, by the way. It still packages your messages, it still tracks the connection state, and it still answers some of the protocol's own background checks by itself. What's gone is the model. There's no request that a response belongs to anymore. Nothing is waiting for an answer because nothing asked a question. Which brings us back to that bug report. When you call send, you get nothing back. Not a failure, not a confirmation. The call simply returns. Send is not a delivery receipt. It tells you that you handed the data over, and that is all it has ever told you. And open doesn't mean what it looks like either. It means your browser currently believes the socket is open, not that anything you sent has arrived. So real chat apps build the receipt themselves. One common pattern is simple. The message goes out with an ID attached, and the other side sends back a small message saying it got that one. Nothing in the protocol asked for this. It's an ordinary message that somebody decided means something. And once you have it, you can finally be honest with the person using your app. You handed the message over. Then your server took it. Later, it reached the other person's app, and later still they opened it. Those marks beside a chat message stand for states like these. WebSocket defines none of them. Somebody had to design every one, which raises a harder question. What if nothing comes back at all? Someone's phone goes into a tunnel. Someone closes a laptop lid. The path between you can be broken. while your browser hasn't discovered it, because something in the middle closed an idle connection without telling either end: a proxy, a mobile network, a company firewall. And your app isn't confused about this, it's confident. The close event you were relying on may not fire for a long time, so the reconnection code you carefully wrote never runs. As far as your app knows, there is nothing to reconnect. So, how does your application find out in time? You make noise on purpose. That's all a heartbeat is: a small message on a timer and a reply that comes back, so that silence starts to mean something. The protocol does have its own version of this called ping and pong, but browsers don't give it to your code. So, in a browser app, the heartbeat is a message you invented, and the timeout is a rule you chose. Good. You can detect a dead connection now, which means you have earned a new problem. If every client reconnects the moment it notices, they all come back at the same instant, and they all arrive at the server that just failed. So you have built a small denial of service attack against yourself. The fix is quiet. You wait a little longer before each attempt, and you add a small random delay on top, so nobody comes back in step with anybody else. Recovery should spread out. You're reconnecting, and that raises another question: how does the server know who you are? This one surprises people. The browser's WebSocket call takes a URL and an optional list of sub protocols. And that is the entire list of things it takes. There's no place to put an authorization header, the way you would on a normal fetch request. So you choose something else: either a cookie the browser already sends during the handshake, or a message you send the moment the socket opens. Either way, this is a design you have to pick. WebSocket doesn't pick it for you. And there's one more: everything works, more people show up, so you add a second server and a third. Now, one server is holding your connection for as long as it lives, and the person you're talking to may be connected to a different one. Your server has no socket for them at all. It is holding a message for somebody it has never met. So your servers need a shared way to pass messages between themselves. And that isn't a setting you turn on later. It's part of the design from the first day. So when is all of this worth it? When both sides genuinely need to speak. Chat, collaborative editing, games, anything where what you do changes what someone else sees. When the traffic is mostly one way, server to browser, there are simpler ways to send it. And you'd be paying all of this cost for a conversation that only goes one way. And if an update every so often is good enough, a plain request now and then is still a perfectly good answer. Plenty of very serious software works exactly that way, quietly, without any of this. One last thing. For the classic connection we've been following, everything travels over a transport that keeps bytes in strict order, and that choice is doing more work than it looks like. A connection that keeps everything in order also makes everything behind a missing piece wait for it. Underneath every layer we drew today, there's another one holding it up. Going one layer down is what this channel does. If that's the kind of thing you want to understand, subscribe.